Okay. Welcome to the panel entitled Breaking Down Bio-Based Feedstocks, Moving Away from an Overreliance on Petrochemicals. I'm Amy Congdon. I'm the Chief Design Officer at BIOFABRICATE, and I'm thrilled to be joined by three incredible panelists. I'm going to let them introduce themselves, but I'm joined by Naeimirad of SENBIS, who's the Innovation Development Manager, Natalie Ashdown, who's the COO of EVOCO, and Daniel Kaute from EVORALIS and CEO. So actually, before I begin, I realised I've actually been briefed several times and I've already forgotten. There should be, at some point, a QR code that appears above my head. That is for Slido. So you can put your questions to the panelists throughout the session and we'll get to those at the end. So use that QR code. It's fairly self-explanatory. I'll remind you halfway through in case you forget, but please do queue up your questions to put to the panelists when we get to that section. So to start off, I would love for you all to briefly introduce yourselves, tell us about your company, what you do, and sort of where you fit in the material life cycle. Because I think we've got an interesting array that sort of spans the life cycle of materials on stage today.
Hello, everyone. My name is Momo, and I am Innovation Development Manager at SENBIS. SENBIS is the continuation of the R&D department of old AkzoNobel from 1952. Akzo was the developer of viscose fibers for the first time. Later on, played very important role in polyester, nylon, and also Tuaron. But in 2000, sold out the businesses and started paint and coatings. But my colleagues kept the R&D facilities, pilot lines. What we offer, what we can do in the value chain, textile value chain, is from the monomer level up to the yarn level. That means we can do polymerization in different scales, pilot scale, laboratory scale. From bio-based monomers, recycled monomers, and so on, we can do extrusion or even solid-state polymerization, and then afterwards extrusion of monofilaments and yarn melt spinning from the SENBIS Polymer Innovation as R&D service for the customers. At the same time, we are developing our own products, which are biodegradable alternatives for polyester, polyamide, polypropylene, etc. And the yarn, monofilament, trimmer line, all biodegradable. And Biofurb is one of the textiles which is in the fashion industry introduced. And if you have any questions about that, about our services for the clients, and the Biofurb, you can come to the Biofluff stand and ask him or me, which is in the back of the cameras, and I'm available. Sorry.
Thanks very much. Yeah. Natalie.
Hi, I'm Natalie, and I'm CEO and co-founder of EVOCO. Yes.
I've invited you.
So EVOCO utilizes plant-based chemistry to reduce our reliance or hopefully replace petrochemistry. We use it to replace petrochemistry. We create high-performance biomaterials, and we make sure that they are easily integrated into existing supply chains. Some of the examples of the materials we create are foams. I've got this example here today because when I talk about foam, I often get a blank stare, and I don't think people realize how much we use foams. We sit on it, we sleep on it, we drive in it, we fly in it, we walk on it. And so when we started out, we realized we had quite a cool foam, but we focused on footwear. So this foam can be created into footwear components. We've partnered with many different global brands, and we've created millions and millions of pairs of insoles. But we didn't just stop there. We realized that we had a fantastic technology platform, and we could apply this technology to create many different materials. So that's what we focused on today, is creating biomaterials that are high performance, that can fit into different supply chains and be applied in different technologies. So we have a coating and adhesive technology that we're working on commercializing today, and that can be used in many different things, from cosmetics to paints. And relevant to this show is it can be used to create leathers. And what's great is that we try to create materials that can just simply drop into existing systems and be very similar to the materials that we're using today.
Okay, thank you. It's nice to be in a round with a big chunk of the circularity supply chain. We're on the other side. EVORALIS develops enzymes that are made for plastic degradation, and they're there to enable large-scale recycling of plastics, in particular polyester, nylon, and elastane. We are a spin-out from Cambridge University. I'm co-founder together with Josephine Holstein and Mariana Rangel. And they have actually developed a process which allows enzyme development 1,000 times faster. It's a bottleneck, 1,000 times faster than state-of-the-art. And that means the overall enzyme development is about 3 times faster than state-of-the-art. And we are working with recyclers, so we enable people to recycle. We are working with recyclers to make large-scale plastic recycling possible. I think that's it. Thank you.
Great. Thank you all. I think as sort of a starting point, I think it would be really good to define what a feedstock is, just to have that sort of base level. I think maybe people have different understandings or different levels of understanding when it comes to that. So in a very simple way of putting it, a feedstock is any raw material that is used as an input into a process to produce something else. I know that everyone would agree with that as a very basic sort of definition of a feedstock. So let's just start by sort of clarifying what we mean by bio-based and what distinguishes sort of bio-based materials from fossil ones, and sort of just give a bit more detail on what a feedstock mean in the sort of the context of your business and more generally. Yeah. Wants to.
Feedstock, because we are covering from the monomer level to polymerization to make a polymer with the right IV, with the right crystallization behavior for the spinning. We use different feedstock from our clients to make their polymers, and some of them are bio, like lactite, like BHET, which is recycled from the polyester items, or bio-based, the bio-MEG, and so on. And nowadays there is a lot of interest for the bio-based feedstocks. And a lot of companies, they are working and they are making, I think, from the agriculture waste, from the sugar cane, from starch, and so on. But we use for our clients what feedstock they have. But for ourselves, we always rely on the mostly commercially available biodegradable polymers.
I actually wanted to come to you and say, you sort of source a variety of different feedstocks. What are you looking for a good feedstock in terms of, both sustainability and scalability, most importantly?
For us, it's all about efficiency. So when you're looking at a feedstock, and particularly in agriculture, you want to look at a feedstock that is highly efficient. So firstly, you want to make sure that the feedstock, the yield per acre is high. Because when that yield is high and it's efficient, it means that it's going to use less fertilizers, it's going to use less water, it's going to use less pesticides. And with regenerative farming today and new technology in agriculture, it's really creating a new environment for great feedstocks. And then we also look at how efficient the feedstock is in creating the chemistry, because that's also really important. Because a second generation or a waste stalk is not nearly as efficient as the primary starch. And so that needs to be taken into consideration. And then also when you're working with highly efficient agricultural feedstocks, you're not taking from the food chain either. And so that for us is really important. And then we also look at making sure that our technology can be based on a feedstock agnostic concept, which means that we can utilize feedstocks or chemistry from feedstocks from around the globe. Because often with agricultural feedstocks, you'll get variability that a lot of technologies battle with. And so for us, we'll look at that, and we'll look at that primarily so we can scale. Because you need to be able to have a variety and a collaboration of different feedstocks so that we can actually scale the technology.
It's really sort of building in that ability to work with, figure out where those sort of compromising points, where you where you need to compromise, but first and foremost,
Yeah.
really focusing on the feedstock, that it will work across different platforms. Danny, your work comes sort of at the other end of
Yes.
the material life cycle. How do you evaluate feedstocks? And does the sort of the initial chemistry
Yeah.
that goes into making something, how does that affect your ability to sort of break it down and work with it at the end of its sort of use?
So thank you, Amy. So fundamentally, we are feedstock agnostic. If we have a polyester-based chemistry, our enzymes do not care whether it's polyester that comes from fossil fuels or polyester that comes from bioplastics. What is important is the economic viability. And that means that you have to have enough feedstock available locally to have, say, a 20 to 100,000 ton plant. If you have to start transporting feedstock from across the world, it will make the process not viable at the large scale that we're targeting. And so these logistic issues are actually one of the most important ones for making plastics recyclable so that they are economically viable.
So many things, yeah. Some things become a systems as well as a chemistry challenge. So I think sustainability is essential, of course, and is driving all of your businesses. But I think functionality really does drive adoption. So
Absolutely.
what are the biggest performance or production challenges that you face when working with bio-based, or sort of any sort of inputs? I think you were talking about the ability to take different feed sources, and that it's not something that becomes a bottleneck or a problem in your process, for example, or when you're spinning fibers or producing textiles, or what are you looking for, and what are those issues that you might encounter with those sorts of feedstocks?
I want to first differentiate between the bioplastics that are between bio-based and biodegradable. When we are saying about bio-based, is coming from bio-based feedstocks, regardless of being biodegradable. But when we are talking about biodegradable, is no microplastic is degrading by the microorganisms in nature, regardless of being fossil-based or bio-based. About your question about the performance, normally bio-based feedstocks, if they are purified very well, and like I'm talking about like bio-based polyamide 6, if you have a very good bio-based caprolactam, and you can polymerize it, you can get to the right RV, then everything would be the same. Like polyamide, it will go, and then it's not biodegradable at the end of life. It's the filament yarn, the same, and almost the same, even recycled one, but we are talking about bio-based here. But when we are talking about biodegradable, that most of the biodegradable ones can be also bio-based. Biodegradable polymers, they are thermally degradable. The crystallization behavior is a little bit poor compared to the normal polymers like polyester or polyamide. And the processing should be different, gentle and so on in the spinning. And later on, also we need to consider the thermal degradation behavior in the drying process, finishing process, and the service life, and so on. But about bio-based feedstocks, it depends which monomer and which polymer we are going to make. If we are talking about polyamide 6 and polyester, is for us is the same. If they give us the good monomer or dimer for a starting point.
So for you, it's really all about the preparation of the
Yes.
feedstock, and then making sure that you're handling whatever that you're taking through the process in the best way
Exactly.
possible.
Exactly.
I don't think we've had too many issues in production because we had a background in biofuels, and I think by the time we got to using biochemistry, learning from what happened in biofuels, you had to create very resilient materials. And so part of what we set out to do is that we knew that early on, if we're going to create a material, it has to be resilient, it has to be feedstock agnostic, you have to be able to just get in there and produce it. So I don't think for us, production problems were too much of an issue. I think trying the education of the consumer and trying to balance out how do biomaterials match performance versus being biodegradable and being 100% bio. And I think, really learning where the consumer is at. The consumer today compared to pre-pandemic was all about sustainability and, paying a premium for products. Whereas today, I think the biggest issue that we find is actually meeting customers where they're at, making sure that we're producing high performance materials so they match on performance, because a lot of sustainable materials don't. And then dealing with the concept, or the counterintuitive concept, that all materials that are high performance must also be 100% biodegrade. And I think what we have to realize is when sustainable materials are actually meeting on performance, they're not necessarily going to match all those criteria. So I think, just taking it a higher level than what Mo went into in terms of biodegradability, our problem is matching or meeting the consumer where they're at.
Yeah.
I mean, nodding there, Daniel, but do you find that what does that process look like for you when you're working with a sort of your customer, and that's walking through that sort of that balance between sustainability and sort of end of life or sort of sustainability questions, and how do we navigate that as we talk about? Sometimes those things can be at odds if you look about sort of very high performance and then talking about what the options are at the end of life. So sort of how are you navigating that sort of those conversations with partners?
I think today there are a lot of people who understand. And what's been amazing for us is partnerships with ambassadors within companies, the big companies. And just understanding how to work with those ambassadors, because I think a lot of what we were actually talking about earlier is that even if you have a fantastic sustainable material and it meets the performance criteria and it meets on cost, because cost is a big one. Most of the big brands have like 20,000 different materials in their supply chain. And to change one material out is a huge undertaking. So unless you have those ambassadors in the company willing to undertake the change, it sometimes doesn't happen. So that's actually more of a problem. Or, someone in a big company will be like, it's got to be 100% biodegradable and it's got to be 100% bio and it's just got to be this, otherwise we're not even looking at it, right? But what about performance? And what about the different solutions that you can use? Like you can recycle, you can biodegrade. There's so many options with new technology that are coming out. And I think with AI, it's going to become easier and easier for companies, big companies, to be able to implement new materials.
Yeah, I come to you, Daniel. I think that sort of that question around is biodegradability the sort of the answer always, or the sort of the work.
Biodegradability.
Yes.
Well, for me, the ideal material is bioplastic, is biodegradable, and 100% recyclable. Why? It's different buckets. Bioplastic, you are saving a resource which is rare, which is biofuels. Biodegradable, you have energy in that plastic. It's a resource. You're not throwing it out. You're not burning it. You're not just letting it rot and lose that energy. And biodegradable, well, 30% of microplastics are based on textiles and they end up in our brains. So it's a very different bucket, but I don't want them to end up in there and you can take out a spoonful sometime later. It's a different bucket, but ideally we should cover the three.
I just love to add to that. I think it's such a complex issue, and we could probably spend the whole time, so I'll be as quick as possible. But it's a social issue as well. Like if you think about how much recycling we've actually done, after all the investment, all the learning that we've put into society to help us recycle, we're only recycling 10%.
1%.
Right? 1%.
Fiber to fiber.
Yeah.
Fiber to fiber. Or, global recycling of paper, plastics, everything is like up to 10%. Like we're just not making a dent. There are still countries shipping waste to places like Africa. And so when you think about people, the majority of the world are trying to think about their next meal, not recycling. It really is up to us as material makers and innovators and recyclers, and it's up to us to make sure that at the end of the day, the material can either be recycled and stay in the loop longer, or it can biodegrade. Because when it ends up in Africa, it still needs to be able to biodegrade.
not necessarily, because if in Africa or in Asia, where the Pacific thing comes from 5 countries in Asia, including Philippines, China, India, Indonesia, if you pay $40 per ton of plastic, that plastic will not go into the ocean anymore.
Yeah.
And so by having recycling facilities and having a market for waste plastic, you can solve the problem of plastics in the ocean. And coming back to both your points, very good. If the material is not performing, forget it. Just forget it. It won't go in. Even if you have an ambassador, it won't go in. And it won't be performing if you can't purify it properly. The moment you purify it, as Momo said, it's the same thing as fossil fuel based because the molecules are the same. So the third factor, why we only have 1% recycling, is recycling textiles is much more difficult than recycling plastic bottles and recycling many other things. Why? Because textiles are 99% mixed or blended. So polyester, cotton, polyester, elastane, everything blended together. That makes it difficult. And you can recycle them. The next thing is to recycle them at cost. And that's where everything has to play together, from collection to sorting to recycling to purifying and coming back.
Actually, to that point, it would be great if you could speak a little bit more. It's why enzymatic recycling and what that offers. And for anyone who doesn't know what that sort of entails, why it's a sort of a choice at end of life.
So what we need is the end result. It's not about enzymatic or chemical or mechanical. It's the end result. Right now, with chemical and mechanical recycling, we can do 1%. It's getting a bit more, but it's still around 1%. The big promise of enzymatical is it's a natural product. It's a protein that catalyzes a reaction that splits the polymer back into the monomers. It's environmentally friendly, and most importantly, it's selective. If you get textiles and throw them into a big bin, everything that you collect on the street, you have about 50% polyester, and the rest is a lot of cotton, elastane, nylon, and acrylic and others. So with enzymatic recycling, you can pull out just the polyester and recycle. You need to purify still. Then you pull out just the nylon, then just the polyurethane, and you're left with cotton. And every single one you can recycle. There are methods out there like circ, excellent methods that can tackle certain problems like poly, cotton, and it's fantastic. We need as many of these successful as possible. But in order to scale, you need something which can selectively pull it out without throwing away one. Many of the recycling methods, chemical ones, you get the cotton, you throw out the rest. Infinited Fiber, fantastic company. They take the cotton, but up to 12% other stuff they throw out. With our technology, we could help them recycle that as well, so you get a truly sustainable approach. And what is important, it's scalable. So we're not only talking about doing a few percent of the textiles out there. With this method, we can make 80% of textile waste recyclable.
I would like to add to the statements by Daniel that I want to give just some numbers. I'm sure some of you know about that. The global consumption of fibers is 110 million tons per year. And polyester alone is 60 million tons. If we consider bottle industry, it would be plus 20 million tons. For the bottle industry, 130 million, and the second rank is cotton. And if we consider packaging and automotive industry, etc., is 420 million tons of plastics produced every year. That means around 1 million ton per day. 1 million ton per day, in a general term, is enough to fill the Manchester United Stadium full of plastics. And the polyester is the second after the packaging in textile industry. They mentioned that only 1% is recycled at the moment.
Fiber to fiber.
Yeah, fiber to fiber from textiles. And while we need to consider 7% of plastics, and I don't have the number now, 500 tons per year is ending up in the oceans. And the microfibers play 35% of the microplastics in the oceans, and the NGOs like Plastic Soap Foundation, Oceans, etc. They want to avoid that, but we believe that by reducing the global warming, by moving to bio-based building blocks, but still we have the microplastic issue, and we are trying to tackle that with avoiding the fiber literation and biodegradable alternatives. And we use AI, Natalie mentioned, AI is a good tool, to design a new polymer in Europe-funded project Biotech, to design a totally new polymer as a drop-off. Because PLA is successful, but we see in the textile is not very good. They are not interested in that. PLA is bio-based, is fully recyclable, is no microplastics. All is there. But
not the
still,
performance.
all the bioplastics from 400 million tons, they have only 1% of the market, and still room for increasing the demand, and that one.
We would have to ask Natalie to make a highly performing PLA, which can compare to cotton. Then we would sell more.
Yeah, we don't make PLA.
Just a few things to be
Add
working
to the
on.
list.
Before we move on to anything, I just want to draw everyone's attention back to the QR codes. If you do have questions, feel free to scan that so that we can get to them at the end. Although I think we could just keep talking. Probably we could just keep going.
We could.
There's so much to cover. I mean, Natalie, actually talking to sort of when you're developing materials with brands and things, are there sort of key considerations that they should be keeping in mind, you know, for the sort of end of life of their materials or their products, or how? Yeah, sort of what's that process of guiding them?
I mean, I think it's a complicated task for the designer at the end of the day. The responsibility and understanding what's going to happen with your product at the end of the day. How are you going to recycle it? Is it going to biodegrade? And I think it's really complicated because you don't know what your end consumer is going to do with it. So I think really, as we all have spoken about, like biodegradability and recycling really are, you know, they go hand in hand. And I think we need both. And I think we need to consider both. But I think when you're considering a biomaterial, you need to consider the supply chain risks. Are they going to be able to deliver in terms of supply chain? You know, what quantities are you working with? If you're a small designer, it's less risk. It's great. You can take on new biomaterials. If you're a bigger player in the market, you know, you want to make sure that you can produce hundreds of millions of, you know, textile or like yards of textile or pairs of shoes. So those are things that as a designer you need to consider, like where is my material coming from and can they fulfill what I need?
Yeah.
I mean, I feel like now I'm going to get to a point which is often sort of an elephant in the room in these conversations, and we're not going to get to an answer to it in this session, but the sort of that bio-based materials often do carry, or at the moment are carrying, a bit of a cost premium sort of attached to them, and talking about how do you get from those sort of smaller scale to larger, you know, real integration into supply chain, sort of, you know, sort of what is driving that sort of increase in cost, and what needs to shift, or what would be ideal to help sort of shift things to bring prices sort of closer to the petrochemical based counterparts of which all these new materials are being held up against in terms of, you know, price and performance.
I can talk a little bit to that. So I think obviously it's the infancy of the supply chain. Petrochemistries had years and years of investment, government subsidies to build a mature supply chain where they could reach economies of scale. And I think for a lot of our technologies, it's reaching the economies of scale that is an issue. And it's a little bit unfair that we're having to compete on price when we don't have the mature supply chains. So I think that's one issue that has faced us. And how we try to solve that is we create a drop-in solution. So, you know, sort of leverage the existing supply chain as it is, and then create a solution that can be integrated into that supply chain and into the existing equipment, because often you need new equipment that could be really expensive. And so we've tried to create a technology that can be used in the traditional equipment that's out there.
Yeah, is there anything from sort of your perspective, Momo, and the sort of work that you're doing developing for brands and?
Yeah, the price is a driving factor and also a barrier because you have polyester there increasing every day, and the price is €1 per kilogram, the material. I think the recyclers even have the same issue, because when you're recycling or bio-based, why polyester still is 50% bio-based, only bio-MEG. They can make terephthalate acid as well, but the process is hard and the purification is hard and it's expensive to make it. I think in case of polyamide 6 is better, easier, and the price and which is coming from. First is the building blocks like monomers, as the feedstocks that we talked, or making the monomer, and then purification, and then I think the material and process plays a very important role. The cheapest biopolymer now in the market is, again, I think PLA. That is even price is sometimes for some applications like textiles is a barrier to use, and by increasing the production capacities, and I think the price will drop. And the target of European bioplastics is also to promote more by putting the policies, regulations for the brands, and I think the brands are the locomotive or driving wheels for the whole textile value chain. Mm-hmm. If the Europe Commission force them, or other organizations, UN, etc., and then they ask about now is 25% recycled or bio-based, and then if they ask the weaving mills, they will ask for the yarn, and then I think the value chain will move in that direction.
I agree.
Yeah. So this is probably the biggest issue that we have. And the question was originally, do these small collections help us?
Yeah, I mean,
with a small collection, you can get a 100% premium, sometimes perhaps more. I was talking to somebody here and they said, well, initially our fibers are 30 times more expensive, and then they'll get down to 10 times more expensive. And if we're at scale, we're at par. Well, the issue with that is that if you just have a collection, you have perhaps hundreds of tons, and you can get a 100% premium. Doesn't help you if you're 30 times higher. And then, very important, companies like H&M and Inditex have formidable sustainability programs and trying to work and trying to help. But if you increase the price of fibers to them by 20%, not by 100%, not by 30 times, by 20%, the profit goes down by 10 to 50%. 50% or even 10% reduction in profit, nobody does. And we're only talking about 20% green premium. That's the big gulf. And that's the issue. That's why we don't have big fiber recycling. That's the issue that we have to work with. The European Union is trying to do this, but they have to do it right. I don't think all the answers are there, because we have the need and we have the reality, and we somehow need to bridge that gap.
I mean, I know for a lot of startups, there's a choice to do those sort of capsule collections often can be driven around to unlock investment to maybe help to get to the next stage in your scale. But what is your sort of thoughts on maybe collaborative projects with groups of brands, sort of consortiums around sort of spreading the risk, sort of for any of your businesses here, whether it's about sort of that coming up with a system to bring those feedstocks into your sort of process, Daniel, or it sort of in scaling materials that you two are making? Sort of what are your feelings on those?
Our experience. So I love collaborating. It's one of my favorite things. I think today at the expo we did a little collaboration already. So And that's what I love about Europe. Europe is into collaboration. All our partners in Europe love collaborating. They don't want to take your technology. They want to work together to find a great solution. I think collaborative projects are essential because they bring new technology to market. They make us aware of what's out there. It gives a new technology an opportunity. But I think if we're going to make a real impact, impact is made at scale. So you need to take on legacy projects eventually, and you need to actually take on proper, like full projects within global brands. And that's really when we're going to make an impact. But I think collaborative projects are really essential for new technology and driving technology.
Yeah, I can only agree. So even though we could be competitors in many cases, or even if not, but even if it's competitors, the market need is so big. There's space for everybody. It is very important that we get solutions, and these solutions are better when we collaborate. This is especially true if you integrate through the circle from collection to sorting to recycling to purification, repolymerization, and then recreating product. If one of these links doesn't work, for instance, right now, sorting does not work because of certain dogmas in the system, it's too expensive, the whole circle won't work. So it's very, very important that we work together and solve the whole thing globally. Otherwise, none of the parts will work.
Well, I think
I can just add one thing to that. And just to reiterate, it's not just collaboration with technologies. It's really collaboration with designers, with the different brands, because we all need to work together. And often technologies are not seeing your side of the picture, right? So when we can work together and we have these collaborations, we can change our technology and adapt it when we get the information, and then we work together. So it's really like a collaborative effort is needed throughout the value chain and supply chain.
Right.
I think the policymakers, the most important fashion brands, technology providers, and later on manufacturers should be collaboration between them.
Absolutely. Otherwise, it doesn't work.
Yeah. Great. Well, we've got a lot of questions. I feel like we're not going to get through them all, but we'll grab these guys off the stage when we finish. We'll try and get to as many as we can. So first up is from Charles. Can textile recycling processes cope with biopolymers, or do they contaminate, e.g. RPET or RPA production? So can textile recycling processes cope with biopolymers, or do they contaminate?
Normally, yes. It can process biopolymers if they're based on the same chemistry. So if you want to develop enzymatic recycling for a completely new chemistry that is so expensive that only works if there's enough volume. There's only enough volume for polyester, nylon, polyurethane, perhaps acrylic, nothing else. Well, cotton, but that's a natural fiber, and that's already being done. So yes, it can be done, but realistically only if the chemistry is right.
PLA is recycled today. There is a
there are other
PLA,
methods. Yeah.
With a specific, Total Corbion is making that.
Yeah, PLA you can also do enzymatically.
If there is a good waste stream, as you mentioned, is.
Yeah, and then we have a question from an anonymous poster. Why can't biopolymers from the waste of food feedstock be used, so like the stalks of corn, because we have 1 billion people on the planet living in nutritional poverty. So what is the issues with using the sort of the non-food part of a crop?
They're just not as efficient. And I know this food versus fuel issue always comes into play, and it's a very sensitive topic, but the reality is that biochemicals are using 0.1% of arable land, and of that non-food crop, because it's a crop that actually, like for example, second generation, industrial corn, it's not actually used in the food chain. It's used for animal feed. So animals take in protein and the fiber, and then there's a starch stream that they don't feed to animals because it bloats them. And so that starch stream is what we're using, and we're already using it in cosmetics. We've been using it for hundreds of years in carpeting, in coatings and adhesives. And it seems okay for us to put it on our faces, but as soon as we're talking about using it in textiles and materials, it becomes a big issue. And so just to put it into perspective, it's not that it's competing with food, and it's always important to think of that. And it's not that we don't want to use it. It's just one of our available biofeedstocks, because there are so many. There's like fiber waste, there's algae oil, there's all sorts of different things. There's algae fiber, and there's so many different technologies to make materials from different parts of plants. So I think it's not that we can't, but what we have to think about is efficiency, because we also have to think about sustainability. And so that's really what you have to focus on.
But actually, a question I would say could be a bit of a follow-up, which is which biofeedstocks seem to be the most scalable currently, and I'd probably add on scalable and also the most sustainably scalable.
So to be honest, they're first-generation feedstocks, and they are the ones that are highly efficient. So you're going to use less water. Water is really important, and we have to conserve water. And we'll use less fertilizers. Fertilizers are a problem in LCA. They cause eutrophication. You'll use a lot less pesticides. And you're not really using a lot of arable land when you're creating these non-feedstock first-generation materials. So I think that's something that we have to consider. Yes, there's a lot of food waste that is being turned into biochemicals, but the issues with that is there's such high variability that scaling it is an issue, because dealing with the variability and then creating the chemicals where we see a lot of the problems.
Yeah, I mean, there's an interesting question here on should the textile industry take more responsibility for the end-of-life collection and reprocessing of the waste being created? So,
Which industry?
The textile industry. Should it take more responsibility, and what would that, and how would they do that, or what would it look like?
I can answer
That
that
one.
one.
To you, Daniel.
So there are schemes like with H&M that you can bring your clothes back into the stores. They collect about 5% of what they sell. They don't only collect their own brands, but anything you bring there. This is a very expensive way of doing things, not that it's a bad way. In order to scale this, we really need curbside collection. And with curbside collection, we need to make sure that only waste textiles go there. So you sell good stuff via platforms, or you give them to charities, and the waste goes into curbside collection. If you do that, you can get a waste stream. A waste management company can bale a ton of stuff for $1,000. With that price, for $100. At that price, if you don't add too much cost afterwards for sorting, you can recycle and be economically viable. So I think this is a problem which needs to be addressed on the waste management scale and cannot be addressed logistically and economically viable at the fashion retailer scale.
Actually, there was sort of a follow-on question to that, which is sort of this extended producers' responsibility, and so actually to Momo and to Natalie, sort of how does extended producer responsibility impact your work and the products that you're bringing to market, or is it at this point?
Well, when we design, we're always designing with 4 main pillars in mind. We design with performance first, because we have to match performance. We design with our LCA, so we use our LCA throughout our design cycle. And then we design to fit into the existing supply chain. And then minimal end-of-life impact is also really important. So those are our 4 concepts. So we do our part in making sure that when you use our material, that there is an end-of-life, or it can be recycled. And so that's our responsibility, but it does become the responsibility of the designer. Like, are you designing a small collection, targeting a different socioeconomic group who have access to recycling and can easily recycle those clothes? Or are you targeting mass production at a level where your end consumer may not have access to an easily recyclable pickup situation? So I think that's where we work together and create materials or technologies that can help with people that don't have the education or the access to infrastructure to be able to recycle.
And I think because we are working on biodegradable products, we are selling value, and I think there is a good responsibility about the people because the price is premium a bit, but they are willing to buy biodegradable trimmer line, muscle socks, or even clothing items and so on. And I think when you are selling value, it's discussable.
Amazing. Well, I want to just take a moment and thank my amazing panelists. We are out of time, and you all came through with so many great questions that we didn't get to anywhere near all of them. So please come and grab the panelists and sort of ask them to them directly. And yeah, thank you for attending, and thank you guys for such a great panel.
Thank you so much.
Thank you.